Hello, and thank you for joining me today as we get to learn about estimating regression parameters. Today we're going to focus a little bit more on the engineering applications, but of course there are many more as we go through. We're going to start with the regression formula. Essentially what we're doing is through regression we're finding the line of best fit through our data plot in order to find any correlations or any significance in the relationship between the two data points. And of course, on the left, you're going to see what looks like a linear equation for our regression line. And then on the right side is our formula on how to actually find the slope of this regression line. Okay, so we're going to use something that's called the least squares method. Through this method, we're actually looking to minimize the sum of the squared distances between the observed values and the fitted values. And by doing so, we find the best line that will help us to fit to our data. In order to do this, we have to find something called the SSA, SSB, SSE, and SST. Now, this is going to be the sum of the squares of our A variable, B variable, error, and the total of these sum of squares. When applying this to engineering, you want to make sure, of course, that you find sufficient data in order to run this regression analysis. And then if you have any data that is non-numeric, such as hair color, such as blonde or brown, you want to assign values such as 0 or 1 in order to run this tool. Okay, by doing this, we can make accurate predictions about the data that we acquired, and as engineers, that can help us to better interpret the data beyond the scope of what we can initially observe. Setting up an example, I made a chart on the left, as you can tell, of the number of a product produced versus the number of failures of that product. And then once plugged into Excel, we get the ANOVA table on the right that tells us many important factors about the regression of that data. Two more models that come up after the Excel analysis is on the left, you can see the actual failures versus the predicted, and then that will give us our residuals. And then on the right shows us the observed values versus the fitted regression line. Inferences we can make from the parameters is it definitely helps us to find the correlation between them, such as an increase in one variable and an increase in another, and how they're related, also if they are significant or insignificant. Another thing we can calculate from these is actually the coefficient of determination. What this is it tells us the percentage of data or variance in data that is accounted for by the analysis of the initial variables we are given. Thank you for watching.